Okay, good morning. Welcome to
FamilyMath number 316.
FamilyMath number 316. So today we were talking about counting the number of divisors of a number. And how do you do that? How do you count the divisors of a number?
Well, first you factor it into primes.
Okay.
Then you make sort of buckets for the primes, and you see how many you can. So, for instance, if you had like 7 squared, then you'd have a 7 bucket, and you could have 0 to 2. You could have 0 to 2 sevens in that number.
Okay, and one of the divisors, yeah. Okay, and then what do we do?
Then we multiply the buckets together.
Okay, how come? Why do we multiply?
Well, because for every, let's say you have 2 times 3, or let's just say 2 squared times 3 squared. For every 2 you choose, you have 2 options to choose for 3. You can choose 2 to the 1, and then you have 2 options for the 3.
What are the options you have for the 3?
It's 3 options for the 3.
Why?
You can have 0 threes, 1 3, or 2 threes.
Okay. So we have a bunch of independent choices.
Mm-hmm.
So we multiply. Okay. So our book, our old Intro to Number Theory book, which we've used a lot and got a little torn up from Art of Problem Solving, has some clever number counting problems. So it says a certain integer has 20 positive divisors. And that's all we know about it, is it has 20 divisors. So the first question on this problem, what is the smallest number of prime numbers that can divide the integer?
Well, we could work backward and say that we could make the buckets first. So we have some number of buckets that multiply to be 20. You have a number in one bucket, some numbers in other buckets, and they multiply to be 20.
Okay.
And then we want to figure out what's the smallest number of buckets, really.
All right.
What's the smallest number of primes that could divide it? Well, right away, we can say that we don't have we have to have more than one prime. Because this isn't a prime, this isn't a square of a prime.
What's wrong?
Well,
go ahead.
So, why do we need 2 primes? We could have we could have a prime to the 19th, and then we would have 20 choices for one bucket.
Very good.
Well, it's the smallest number of prime numbers.
Yeah.
It can't be a square, is what I meant to say. It can't be this number can't be a square of another number.
Why not?
Because squares always have odd divisors. They have an odd number of divisors.
But this is 2 to the 19th, and that's an odd power, so it's not a square.
Yeah. So 2 to the 19th has 20 divisors.
So that could work.
What's another number that has 20 divisors?
Well, like 3 to the 19th.
3 to the 19th has 20 divisors.
Well, really, it's any prime to the 19th.
Would have 20 divisors.
Yeah.
Okay. So what's the smallest number of prime numbers that can divide our integer?
Well, there would be just one prime.
1. Okay. Might be 2 to the 19th, 3 to the 19th, 5 to the 19th.
Any prime to the 19th.
Okay. So let's move on to the next question.
Okay.